Welcome to this video on the inverse operations. So to get us started, I'm going to run through an example with addition and subtraction. So if I've got 5 plus 3, I know that that is 8. But how do I go in reverse? How do I start with 8 and get to 5? Well, of course, I've got to take away 3. So therefore, if we add 3, but then take away 3, we end with the same number we've started, which is obviously 5. So therefore we know that adding and subtracting are inverses. So let's look at another example. If we've got 2 and we add 4, well, we know that that's 6. But how do I get from 6 back to 2? So how do I get from 6 back to 2 so I can end where I started? Well, I've got to take away 4. So again, that just gives us another example of why adding and subtracting are inverses. So we can apply this idea to multiplication and division. So if we've got, 5 times 3 instead, 5 times 3, that's 15. And then if I want to go from 15 back to 5, well, I've got to divide by 3. So 15 divided by 3 will get us back to 5. So therefore multiplication and division are inverses. And let's look at one more example for multiplication and division. If we've got 4 times 2, we know that that's 8. But then if I want to go back to 4, if I have 8, I've got to do 8 divided by 2 in order to get me back to 4. So we can think of inverses as undoing. If we do something, how do we get back to where we started? Well, if we added, then we've got to subtract to get back to where we started. And if we've multiplied, we've got to divide to get back to where we started. So in the next part of the video, we're going to have a look at a specific example of an inverse, and that's called the multiplicative inverse. Let's talk about the multiplicative inverse and identity. So what are those things? So I'm going to start with the multiplicative identity. So if I've got 4 times 1, well, 4 times 1, I know that's 4, so anything times 1 is itself. So I'm happy with that. This 1 has a very special name, and that is the multiplicative. So multiplicative identity. Why is it called that? Well, in maths, we give the name identity to something where we use an operation and the number that we used originally remains unchanged. So here we've got 4 times 1 is equal to 4. So we started with 4 and we ended with 4. So it's remained unchanged, so we have times by the multiplicative identity. So that's why it's called an identity. Okay, but what about if we had 4 times something to give us 1? So to give us that identity. How do we work that out? Well, 4 times what will give us 1? Well, it can't be 4, because if we had 4, we'd have 4 times 4, which is 16. So it must be something else, and that something else is 1 over 4. So then this 1 over 4 that we've times by is our multiplicative inverse. So what have I done there? I've taken a number, timesed it by its multiplicative inverse, and I've ended up with the multiplicative identity. So let's have a look at another number. So if I had 5, well, if I times that by its multiplicative inverse, I would times by 1 over 5. And then doing that, 5 times 1 over 5 would just leave me with 1, which is the identity. So another number, so say we had 11. So I would times that by 1 over 11, which is the inverse. And then that would leave me with 1, which is the identity. So I take a number, times by its multiplicative inverse, and I am left with the multiplicative identity. So let's have a look at some more examples. So starting with the first one, what do I have to times by 7 to get the multiplicative identity, which is 1? That's right, 1 over 7. So we've took 7 and we've written 1 over. 3 times what is equal to the multiplicative identity 1? 1 over 3. And then 273 times what gives us the multiplicative identity, which is 1? Well, you're right, 1 over 273. Would knowing this be useful? Well, I've got a question here. I've got 4 times 3 times 2 times a quarter times a third times a half. Why would this be useful? Well, it wouldn't be very nice for us to do a quarter times a third times a half. What we could do instead is we could use our commutative law that we should know, so it doesn't matter what order we multiply things, we get the same answer. So we could say, well, we've got and group the numbers with their multiplicative inverses, so we could get 4 times a quarter times 3 times a third times 2 times a half, like that. Then we could use our associative law, which says that we can group multiplications together. So we could group 4 times a quarter, we could group 3 times a third, and we could group 2 times a half. Then from what we've just known, that when we take a number and times it by its multiplicative inverse, we get the multiplicative identity, which is 1. So we know that 4 times a quarter is 1, and we know that 3 times a third is 1, and we know that 2 times a half is 1. So this means we get 1 times 1 times 1. Well, 1 times 1 is 1, times 1 is 1, so the answer is just 1. So that's far easier than working out 4 times 3 times 2 times a quarter times a third times a half, because we can just use little tricks that we know, like the commutative law, the associative law, and then the things we've just learnt about multiplication with inverses and identity, to help us get to an answer very quickly. Another example, we've got 5 times 7 times 8 times a seventh times an eighth times a fifth. So we can do exactly like we've done in the last question. We can use our commutative law to write 5 times 1/5 times 7 times 1/7 times 8 times 1/8. Then we could use our associative law to put brackets around this. So we get 5 times a fifth, we get 7 times a seventh, and we can get 8 times an eighth. So 5 times 1 over 5, well, from the work that we've done so far, we know that we take a number, times it by its multiplicative inverse, we get the multiplicative identity, which is 1. So 7 times 1 over 7, that's also 1. So 8 times 1 over 8, that's also 1. So we get 1 times 1 times 1, and that is, of course, 1. So again, why have we looked at this question for an example? Well, it's good because it highlights how knowing what the inverse and identity for multiplication are can help us with our maths and help us work out something quicker. So 5 times 7 times 8 times 1/7 times an eighth times a fifth, that's going to be difficult to work out. So we can just take a little shortcut with what we know about identities and inverses for multiplication and some other things like commutativity and associativity, and we can get to an answer very quickly. In this video is why division is not commutative or associative. So if we've got 10 divided by 5, well, that is not the same as 5 divided by 10. Because 10 divided by 5 is 2, and that is obviously not equal to 5 divided by 10, which is 0.5. So therefore, let's write division is not commutative. So we know that that is true. Let's just have a look at another example. So if we have 24 divided by 4, well, we know that that is not the same as 4 divided by 24, because 24 divided by 4, well, that is 6, and that is obviously not equal to 4 divided by 24, which is equal to, as a decimal, say 0.1667. So those two are obviously not equal, so we're happy that division cannot be commutative, because what is commutativity? It means it doesn't matter what way we write things, we still get the same answer. Well, here we've changed the way we've written things, the order of the way that the division is written, and we haven't ended up with the same answer, so it can't be commutative. Here we're going to look at why division isn't associative. So what was associativity, in case you've forgotten? Well, for multiplication, I'll just very quickly write this. We had, if we had 2 times 3 times 4, I'll just write it again. So if we had 2 times 3 times 4, we could group certain things together. So we could write brackets around this, so that's how we group things together with multiplication. So do these things work out as the same thing? Well, let's see. 2 times 3 is 6 times 4. And then for this side, 3 times 4, well, that's 12. So we've got 2 times 12. So 6 times 4, well, that's 24. And 2 times 12 is 24. So that's an example of multiplication and how it's associative. I'll just quickly rub that out. So I've got the same thing here with division, and what we're going to do is we're going to see whether it works. If it does, well then we might be happy that division is associative, but if it doesn't, then we know obviously it isn't. Okay, so let's take the left hand side of this. So we've got 6 divided by 3 divided by 2. Well, 6 divided by 3 is 2, and then 2 divided by 2. Well, that's equal to 1. So let's check the right hand side. So 6 divided by, and then in brackets 3 divided by 2. Well, that's 6 divided by, and then 3 divided by 2 is 1.5. And then we've got 6 divided by 1.5. Well, what's that? 6 divided by 1.5. That is obviously 4. So we've got 1 is equal to 4. That obviously cannot work. So from this, we're convinced that division isn't associative. Let's just have a look at another example. So if we had 15 divided by 3 divided by 5. Let's see if I just write that on the other side. So 15 divided by 3 divided by 5. If I just put the brackets around. So for this first part, I'll put the brackets here. And then for this part, I'll put the brackets around here. Okay, so 15 divided by 3, well that's 5. So then we've got 5 divided by 5. And that's 1. And then for the right hand side, we've got 15 divided by 3 divided by 5. What's 3 divided by 5? 3 divided by 5 is 0.6. So we've got 15 divided by 0.6. And then 15 divided by 0.6 is 25. So here we've got that 1 is equal to 25. We know obviously that isn't true. So therefore, they're not equal to. If I just put actually that they're not equal to for all of these. So therefore, division, so if I just put division, is not associative. In this video, we've looked at what an inverse is. So addition and subtraction are inverses, multiplication and division, they're inverses of each other. So that was the first part of the video. Then we looked at the multiplicative inverse and identity. So we know that the multiplicative identity is 1. So we looked at questions like this. So if I've got 4, what do I have to times by 4 to get the identity, which is 1? We'll have to times by 1 over that number that we started with, so 4, so 1 over 4. And then the quarter is called our multiplicative inverse. So we take the number, times it by its inverse, and we get the identity. And then we had a look at some problems where that was useful. And then the last thing we looked at was why division isn't commutative or associative. So the big thing there is it does matter what way around we divide things, whereas when we multiply, for example, it doesn't matter. Thank you for watching.